For the second part of the worksheet, you say you have a 50 newtons applied force, 30 degrees to the horizontal. It's just pretty much explaining the picture. The main point it's saying is that there's three people, Ben, Don, and Warren, and they're discussing the problem. Ben suggests that the normal force is 50 newtons. Don suggests that the normal force is 75 newtons, and Warren suggests that the normal force is 100 newtons, and they're saying which one's right. We could solve this, but we can kind of just look at it at the same time and kind of like be able to figure it out. Don thinks that the force, normal force, is 50 newtons because it thinks it has to cancel out this. He's almost right, but the problem is that this is at an angle. So it has an x and a y component, so it's impossible for it to really be 50. Now, Warren thinks that it's 100 newtons because it thinks normal force will cancel out the gravity, which it normally would if it wasn't for the y component of this. So it can't be 100 newtons, can't just simply be 50 newtons, so it must be 75 newtons. Now we can actually solve this if we want to. Alright, we can start by figuring out what the y, breaking this force up into its x and y component. We can find the y component by simply doing 50, the hypotenuse, sine of 30, which gives us 25 newtons going up in the y direction. So the net force in the y direction should be 0 because unless it's lifting it too high, which means the normal force, which is always positive, minus the force of gravity plus the 25 newtons has to equal 0. So that means the normal force has to equal the gravity, which is 100, becomes positive the moment we move it over, minus 25. So the normal force has to equal 75 newtons, which makes this one the correct answer. So, who is this guy? So Don is correct. To figure out number 5, fill in the blank for the following situation. PSYW means please show your work. It's the same thing we did before. First thing we want to probably do is break this up into its x and y components. So when we break the force up into, we can find the force in the x direction by saying that the force in the x direction is going to equal to 38, which is hypotenuse, times cosine of 2090 angle. That gives us 33.24. Then we can find the y component by doing 38 sine of 29, which gives us 18.42. From there, we can try to figure out our normal force. Actually, before we finish our normal force, we first have to figure out our force of gravity. The force of gravity, which is just simply mass times gravity, which is our 3 kilograms given to us by here, times 9.81, gives us our force of gravity is equal to 29.43 newtons. So from there, now that we have our force of gravity, we can find our normal force. So the way we find our normal force is, remember that our net force in the y direction should equal 0. So if we look at all our forces, let's make this very clear. If we look at all our forces in the y direction, that means this has to equal 0, which means the normal force, which is positive, minus the force of gravity because it's pointing down, plus the x components of our applied force. It's positive because our x component is pointing up. Has to equal 0. So that means if we move the force of gravity over and we move the force of x over, we find out that the normal force has to equal the force of gravity minus the force of x. So the normal force equals to 29.43 minus 18.42, which gives us 11.01 newtons. Now that we know the normal force, we can actually find the force of friction. We are given the coefficient of friction down here, so we can apply it to our force of friction. Remember, our force of friction is simply equal to the coefficient of friction times the normal force. Now our coefficient of friction is, since our force of friction again is the coefficient times the normal force, and the coefficient of friction is 0.5 given to us in our problem. It's supposed to be an arrow. and we multiply by the normal force that we calculated here, we find that our force of friction is 5.51 newtons. So then when we look at our problem, this is what we solved for so far. Now we can try to find out the net force. Because all the y forces cancel out, the color I have not used. Because all our y forces cancel out because of the normal force canceling out all the problems, the only thing with the net force that we have to really take into account is the net force in the x direction, which is equal simply to our x component, which is 33.4 newtons, 33.24 newtons. Looks like I erased something I needed later. So to find the net force in the x, we take the force in the x component that we calculated, which was 13.24 newtons, and we subtract it from our force of friction because it's pointing in the opposite direction, and we get our net force in the x direction is 27.23 newtons. Now that we have that, we can actually calculate our acceleration in the x, because our net force in the x direction is equal to our mass times acceleration in the x. And they told us that our mass was, I believe, 3 kilograms. So 3 kilograms times AY equals 27.73 newtons. So we divide both sides by 3 kilograms, and we get 9.24. Oops. 9.24 meters per second squared is our acceleration. And while I was erasing things, I accidentally erased our net force, which was 27.73 newtons. So there we have all our variables for that problem. The next problem is the exact same thing, just with different numbers. They changed the mass and the angle and the force applied, but the process is still the same. So I'll leave that up to you and start looking at number 6. It says a box is pulled at a constant speed. The key word here is constant speed. As long as the normal force is, or as long as this force in the y component is greater than the force of gravity, then the normal force should make the net force in the y. Oops. The net force in the y should equal 0. And since it's moving at a constant speed, that definitely means that the net force in the x is also going to be 0. So we can begin to figure out these forces. Just like before, we start looking at this force being applied, because it's being applied at an angle, and we hate angles. We want everything in the x and y component. We break it up into its x component, which is simply 80 cosine of 45, which gives us 56.57, and we find our applied force in the y, which is simply 80 sine of 45, which also gives us, because it's 45, 56.57 newtons. Okay, so if we have to name our steps, we could call this step 1, we can call this step 2, and now if we were to have to solve this, we can do step 3 by finding the force of gravity. The force of gravity is simply the mass times the gravity. They give us the mass, so we just know that the force of gravity is 20 times 9.81, which gives us 196.2 newtons. To find the normal force, we have to remember that the net force in the x direction has to equal 0, so that means the normal force minus the force of gravity, because it's pointing up, plus the force of the applied force in the y direction, which is pointing up, should equal 0. So that means the normal force should equal the force of gravity minus the force in the y direction. So when we actually plug it in, we get the normal force is equal to 196.2 minus 56.57, which gives us 139.63. As for the force of friction, since the x components have to cancel out because the constant speed, that means our force of friction is also 56.57 newtons. And from that, we can find our coefficient, because we know that the force of friction equals the coefficient times the normal force. And we know the force of friction is 56.57, and we know that the normal force is 139.63. So that means that the coefficient has to be 0.41. And that's all of them. So that's that worksheet in a nutshell.